today we're going to be describing how to drive an equation for explicit forward difference in scheme for calculating the time-varying temperature profile. First off, we're going to have to take from part one and reiterate the uniaxial time-dependent heat diffusion equation with no heat generation, which is the partial derivative of temperature over the partial derivative of time is equal to alpha partial derivative of T over, actually it was partial derivative over derivative of X, T temperature over some spatial distance X. Okay, so what's important here is that we can drive an equation from this in a sense to describe the difference scheme or the variance in time for the temperature profile. So let's write out different time frames. So we have at time 0, we can mark off different spatial discretizations. So we have like 1 meter, 2 meter, 3 meter, 4 meters, like 1, 2, 3, 4, 5 at different, and each one of those is going to be different temperature. So we have each one of those are going to equal J. That's going to be, J is just going to equal the spatial discretization. And then we'll have different time frames, say like T is equal to a change in time, and then another one which is going to be a change in time of this one, the second one. So just do 2 change to T. Each one of them are going to be having their own spatial discretizations. Right? Okay. So how do we write an equation from this? Well, we know that on this side, a change in temperature over a change in time, we know that we can say T is equal to we want to know the change in temperature between these temperature profiles. So what's the difference between Tn plus 1 minus Tn J, right? So what's the difference in those over change in time? Okay. So we got to do the forward and backwards of it because we have to change the temperature over 2 changes in times also. So it's going to equal alpha of some change in time over X all over, what's the forward one? So say if we want to find the variance between these two, right? Where this is the time frame right here, N, or the original J, I guess, some space. It would be N plus 1, or T N plus 1. Actually, no, it's all going to be in the same time variance over J. It's going to be J now we can just solve out for the later, or the original time, by subtract or multiplying change in t over, and then distributing this change in x, and solving out for this equation right here, which is the explicit forward differencing scheme for calculating time varying temperature profile. So we're gonna write this all down here. And down. T n plus 1 at a j is equal to alpha multiplied by t j plus 1 at n minus 2 t n j minus, let's write this off, t n j minus 1. Okay, all divided by change in x squared plus to actually multiply it by change in time, and then adding this up here, t and j. Okay. For simplicity reasons, we can turn alpha change in temperature over change in x squared into a variable r. So we'll have this equation right here, plus 1j, is equal to r, actually, let's write this right here, t, and some spatial discretization, plus r multiplied by t n j plus 1 minus 2 t n j minus t n j minus 1. And I believe that is the equation